Okay, good evening, everyone. Today we are going to learn our Chapter 7 single-dimensional arrays. It's a kind of data structure that you will be learn in detail if you if you are going to taking the data structure and algorithm course in the future. However, we still have to get in touch with it in our Java course because we have to use it in our applications. So what is an array? Array is a certain kind of data structure that represents a collection of the same type of data. Okay, as you can see here, here is how we can declare an array. What we have to focus is what we have to focus is after the data type double, there is brackets there, right? And this indicates it's an array. And then we still need the new something, new double, and a double with brackets here indicates it's a number. That means you are declaring how many cells you are going to use, like here, 0 to 9. This is 10. How can I? Okay, here, this is, sorry. This is the 10, referring to this one. And we say my list here is an array reference variables. We can also say it is a variable name for simple, okay? Variable name. But it's a reference type. We have in our exam 2, right? I have asked you what is pass by value. And I saw some of your answers. Okay, seems that you are copying the same thing or maybe using the ChatGPT and you know what is pass by value. But now here we have another kind of type that is pass by reference here. Okay, at this moment, we will not get in touch what is pass by value, but you have to know that what is a reference. Usually we say a reference is a certain kind of a pointer. If you are taking C++ or something, C or C++, it's a pointer that points to an address. Suppose this address is like OX0001, and here is OX0005. This is OX0011 because okay, it's a double, so it may not be the only 4. If it is int, it is 4. We say it is an address. The address for this cell. And we also say that if something is pointing to this address, for example, we declare a variance, and that is my list, right? This is a name. And this name is pointing to the very beginning of the 10 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the beginning. And at each cell, they should have an address. And the reference means that the address pointing to my list, the first cell's address. So you can thinking in such a way that I own 10 house. Okay, I own 10 house, right? 1, 2, 3, 4, 5, 10. And here is 52, 1, 52, 2, 52, 3, until the 10, 52, 10. And this is all my address for my 10 consecutive house, right? So when when somebody write an email sent to me, what he need to do is just send the email to the first place, right? We say to to 52.1. We say this is a reference. Once we can find the 52.1 and we can find the 52.2, 52.3 because each time we just plus 1, right? Here we plus 4 or maybe 5, 8 or 6, depends on the data type here. So that is a reference. We say it's an address. And here is some other ways to declare the array variables. Here we say it is a template. Here is the data type, which is mapping to the double and blank brackets. After that, it's an array reference variable names. That is how we can declare. And also we have another style that is the data type here and my list variable name goes first and with another empty brackets here. Both of them are correct. And when we are going to creating an array after we declare it, for example, here we only declare, right? We don't know here. We don't know the size of the array. So what we have to do is we should creating such an array. That means we are going to using the new keywords, new the data type with the array size. So in the previous slides, we say my list, we knew 10 cells, right? So here it is double 10. And the my list 0 references to the first element in the array. As I have mentioned, reference is to the address, right? Here, can you find the difference for this reference of my list with this one, my list 0? So we can always thinking in such a way. My list is always pointing reference to the first element. If we are not including an index, we say this is index. If we are only using the array list variable name only, it refers to the first element. However, if we are using the index with the array's variable name, okay, it's supposed to reference to the corresponding elements in the array. For example, 0 is going to reference the first one, and this 9 reference to the last element because we have 10, right? But also we can say we are referencing to the 10th element. That is the difference between my list and my list 0. So here is the declaring and creating the array list in one step. We declare it using data type brackets, array reference variable, and then we directly assign the array reference variable with the new data type array size here. This is the whole one-stop way to declare and creating. And also, since we have 2 ways to declare and creating the array list, so these are the second way. And we have to know that in the right-hand side, they're always the same, using the new, double, and the array size. But in the left-hand side, the empty brackets can be placed after the data type or after the array reference variables. So this is the only difference. When you saw any one of the declarations, you should know that they should be correct. No mistake with these two. And once array is created, its size is fixed. It cannot be changed. Okay, this is fixed. And you can find its size using array reference variable dot length. For example, my list, this is the array reference name, right? And dot length. And then this one will return 10 to the invokee method. And this is the initialization of the array for the default values. When an array is created, its elements are assigned the default value for the numerical primitive data types. What are those numerical ones? For example, integer, right? Float, double, long. Those are 0 or 0.0 something. And for the char type, the default value for them is this one. Usually we can say it's this one. And they are the same thing. And for the Boolean types, we have true or false, but the default value is false. And we have to know that the array elements are always zero-based, usually zero-based, but I have to mention that in some other languages, there is also one-based. What is zero-based? What is one-based? For example, for Java, C++, everything is starting from, like, for example, we have an array, right? The index is always from 0, 1, 2, 3, 4. However, there are some other languages, they are one-based. That means the index is starting from 1, 2, 3, 4, 5. As you can see, there are 5 cells, right? 5 cells. Here is also only 5 cells. But their index is different. The first is 0, the last is 4. For the one-based, the first is 1, the last one is 5. This is the difference. So that's why when it starts from 0, usually the last one is the array reference variable name dot length -1. That's why. For example, my list, it has 10 values, right? It holds from 0 to 9. And each element in the array is represented using the following syntax as known as indexed variables. For example, if I want to, using this one, A, B, C, D, E, suppose I have an array and the value they stored are those characters. So if I want to get for example, this is my list, okay? My list 3. So as you can see, you can reference to the my list and go to the 3 position, the 3rd position, and then what you'll get is the character D. Okay, I think is and then chart character. Okay, now the character will reference to D. That is how to fetch the value from an array. After an array is created, an indexed variable can be used in the same way as a regular variable. For example, following the code as the value in my list 0 and my list 1 and assign it to my list 2. For example, here it has something, okay, it's a little bit not clear here since. Okay, here it has something like that. 1.9, 2.9. We can declare something else here. Suppose my list is looks like this one. Okay, we have 0, 1, 2, 3, 4, 5, right? This is index. We'll suppose the value for them is 10, 15, 31, 5, 4, 9. Here it says my list 2. That means this one, the value of it should be changed to my list 0, that is 10, plus my list 1, that is 5. So here we got 25, right? And we assign the 25 to my list 2. That means here the 31 is no longer exists. We have to update it into 25. That's it. And we can also initialize an array when we are declaring and creating them. Here is a way to do them in one step. Here is we declare it is the type for the array is double. Here means that, oh, it's an array. We also here we don't know the size. And then we declare the variable name for the array, that is my list. After that, we initializing the array list as 1.9, 2.9, 3.9, and 3.5. We use a curly brackets to include the 4 numbers, right? So in this case, that means if I invoke the method my list dot length, and it will return 4 to me. Because we only have 4 numbers here. That means when we are declaring, creating, and initializing the array list in one step, that means the value for each array element is fixed. The length is also fixed. And the shorthand syntax must be in one statement. We cannot separate them. For example, like for example, if we separate them like double my list, right? And then we assign the value in the second line, my list is equal to 1.9, 2.9, 3.4, 3.5. Okay, this is not correct. Everything should be in one statement. But, however, the following way is correct. Because we initially create a 4-element array, right? Here is we using new. That means we are creating something. We are creating a 4, 1, 2, 3, 4 empty elements there. And their index is 0, 1, 2, 3, right? After that, we assign the value to each individual element. We assign 1.9 to 0. Okay, fine. And 2.9 to the 1, 3.4 to the 2, and the 3.5 to the 3. And this is possible. This is fine. And we should also have some cautions that, like, if we are using the shorthand notation, you have to declare and create everything in one statement. Splitting would cause a syntax error. For example, okay, here is what I have done in the previous slide. This is wrong. So let's take a look over the trace this program. For example, in the third line, here we declare an array variables, values, and create an array, assign its reference to values. Here is we are creating 5 elements, 0, 1, 2, 3, 4, right? And we new int 5. Here we are all default values. So 0, 0, 0, 0, because we are using integer. It's a numerical type. However, we are going to iteration the for loop, and we will iterate, go through the 5 array cell elements. In each iteration, first I becomes 1, right? In each iteration, the values will become the index plus the values before these elements. For example, here, we are starting from I from 1. This is the starting point because I is equal to 1. So it means value I means the value 1 is equal to the I. I currently is 1 plus value 0. So that means it equals to 1 plus 0. That is 1. And then we assign this 1 to here. And once we have done with that, we increase the I++, and then I now is equal to 2. And as we can see, when we are doing the second one, values 2, let's calculate together. Because current I is 2. It's already plus 1. And the value 2 is equal to I, that is 2 plus values 2 minus 1. That means it is equal to 2 plus values 1. Values 1 is 1, so here is 3. So that's why in the cell corresponding to the index 2, the value is 3. And after this one, I becomes 3 because it increment by 3, right? And the same thing happen. For the 3, it means we should add the index with the previous value, contribute to 6. And also the 4. It becomes 4 plus 6 and becomes 10. And after that, I becomes 5, and the 5 is no longer smaller than 5 because they are equal. So we will exit this loop. And after that, we will update the value 1, which is equivalent to the value 1 plus 4. That means it will equivalent to the 1 plus 10. That is 11. And that is the program with the array. Okay, we will see some examples for the following 8 different categories. Let's go through them one by one. Here we initializing with arrays with the input values. Here we are pretty familiar with that, right? Usually we don't include the java.util because we have already imported them at the beginning of the program. What we have to do is input is equal to new scanner in, right? And then we system out print enter my list.length plus values. And then we are writing such a program to fetch the user input at the value for the created arrays. And we can also using the math.random to initialize the array with random values. That means you cannot decide what the value it is because we are using the math.random method. And here is to finding the largest elements in the arrays. Here we begin with mylist max as the first element. And after that, we always compare the elements after the first one or the next one with the current max. If the current value in the mylist I is bigger than my max, and the max will be updated to the current value. And also we have some method for random shuffling. For example, here, we generate an index J randomly. Here, J, it is randomly generated. And then we swap the mylist I with mylist J. That means we finding the ith element here with the jth element here, and then we swap them. Here is the logic to swap things. First, we create a temp variable to store the mylist I. For example, if mylist I is 3, mylist I is 5, okay, before swap. Okay, and we have an attempt. We have a temp value. It says we assign the mylist I to attempt. That means currently the attempt is going to be 3, right? And then we given the mylist J's value to mylist I. That means we give 5 to the mylist I. That is 5, right? After swap. And once we have done that, we given the temp value to J, right? Temp is 3. He gave it here. He gave it here. So 3 becomes here. So in this case, we exchange the value. And here is also another way to shifting the elements. We declare a temp variable that is to be the first one. We return first element. And we shift elements to the left, to the one position in the left away from the origin. For example, here, suppose we have an element that is 4, that is 4 elements. We say that is 1, 2, 3, 4. What the program done is that shifting them, making them becomes 2, 3, 4, 1. That means 2 goes here, 3 goes here, 4 goes here, and 1 goes to the last. That is a shifting element. And we will introduce a new way for the for loop that we say that is an enhanced for loop. Also say it's a for each loop. JDK 1.5 introduced such a new for loop that enables you to traverse the complete array sequentially without using an index variable. For example, the following code display an element in the variable display all the elements in the array mylist. What you have to do is write the for clause like for something, for double. This is the type, right? Here you can declare it as anything you want. But mylist should be consistent with the array name as you declared previously. And this thing is the individual element should be used inside the for loop. And you can also say that is for double C mylist. It's also fine. So what you have to do is print line C. Just make them to be consistent is enough. But you still have to use an index variables if you wish to traverse the array in a different order or change the element in the array in a different order or change the element. Like you want to update the value for a specific location, or you may want to traverse them in a reverse order, or maybe in some orders in a specific pattern. Here, the enhanced for loop can only iterate from the 0 to last. So you cannot reverse the iteration direction. Okay, let's have a look over some examples here. Here, the problem is to write a program that picks 4 cards randomly from a deck of 52 cards. All the cards can be represented using an array named deck, filled with the initial values 0 to 51 as follows. Here, it creates an array that means a deck. It has 52 elements. That means, okay, we have an array that is indexed from 0, 1, 2, 3, 4 until 51. And here we initialize each card. From the I is equal to 0, that means we are starting from here. When the I is smaller than the deck dot length, that means when I is smaller than 52. Because we have 52 cards, that is the length. And each time we assign the index value to the specific element. That means here, the value stored in the array is 0, 1, 2, 3, 4, until 51. Right? Like here. The first one, 0. This is the index. It's 0, 12, 12, 51, 51. And then we are going to shuffle the cards in a specific pattern. Although we don't have the rules indicated in this problem. So what we have to do is just look over it. Once it gets, okay, it's a random shuffle. That means there is no regular patterns for that. So after random shuffle, 6 will go to the first place here. Okay, it's supposed to be here, right? And goes here. And the 48 goes to the second one, the index 1. Okay, it comes from here to here. Everything is in shuffle. It is in random place. And it seems there are some patterns for the cards. However, since we don't have the description, so we cannot understand it. So let's skip it. It gives us an exercise, but I don't think it will help, so I will skip it. Okay, let's looking over the next topic is copying the arrays. Suppose like we have already initialized, declare, initial create and initialize the array in one line here, right? So we have some other method to copy these arrays to another arrays. Here we say it is the source array. And then we declare a target array, new. We declare same size with the source array length. For example, here is 1, 2, 3, 4, 5. The source length is 5. So here is supposed to be 5. And after that, after we declare an empty array, for example, here, the source array is looking like this. 2, 3, 1, 5, 10, right? And the target array, initially, we only declare there's supposed to be 5 elements there. However, the default value for them is 0 because we don't give them a specific value. But once we have done here, that means we iterate the source arrays dot length. That means we iterate through 0 to 5, right? And then each time we assign the source array I to the target array I. That means we are assigning the same position from the source array to the same position of the target array. That is, 2 is copying to here, 3 is assigned here, 1 is going here, 5 goes here, 10 goes here. That is this way of copying the arrays. However, we still have some other ways. For example, we can using the array copy API provided by the Java arrays. In this API, the first parameter is the name of the source array and the source position. That means the starting point you want to copy. And the third parameter is the target array name and the target position, where you want to start it to copy. And the length, how many elements do you want to copy? So for example, here, source array 0, target array 0, source array dot length. That means we are copying the 4 source array to the target array. But sometimes we only copy partial. Okay, let's take a look over this one. Passing arrays to a method. Okay, as we have learned that a class can be a data type, right? A class can be a data type. However, the array is also a certain kind of class because it has a specific meanings. So in here, we pass the data type int with a blank brackets here as a data type. And here is the parameters name array. When we are invoking this method printing array, what we have to pass is here. What we have to do is passing the list, which is we created previously here. This is the data type. As we can see, they are equal to each other, right? And this is the name. So we just put the name here, and then the 312642 will go here, goes to here. And once we have the array, we can using a for loop to print each element. So what we'll get is we invoke the method print array new int the anonymous array. We can also this is another second way to do so. I think I should separate them. This is referred to the data type. And this is the array. Although it doesn't have name, but it has the elements there. We just created using the new in the parameters. It is allowed. So that is passing array to a method, and then we can use a for loop to fetch the method and get the element from it. So let's take a look over what is an anonymous array. In the previous slides, we say that the print array knew something, right? This is a parameter. This is a parameter. And it creates an array using the following syntax: new data type, and the blank brackets with curly brackets with literal 0 to literal k in between. And there is no explicit reference variables for the array. That means that usually we are going to do something like, okay, we have int, right? My list is equal to new int 3, 1, 2, 6, 4, 2. And then we have create the, usually we should create it, right? And then we invoke the print method, print array, and we pass the name directly. However, we can using the anonymous array. That means we don't give the array a name. Let me change the color. That means we do not using this one. We do not use it. We just directly put this, the right hand side operand directly into here, making it looks like the lines we are using the purple line. And that is the anonymous array because we are no longer using my list to reference it. Okay, then let's take a look what is passed by value and what is passed by reference now. Okay, Java uses pass by value to pass arguments to a method. There are important differences between passing a value of variables of primitive data types and passing arrays. If you can recall in the exam 2, I know I know 2 students using such an example, like for example, I have a method, right? Int change x. And in the change method, x is equal to 10. It always change x to 10. However, when we are in the main method, we initially set x to be 5, right? And then we call the change method. We change x. And then we print x here. Here, x is 5. Here, inside the change x, it is 10. However, after we change the x here, when we are going to print out the x, it is still 5. That means it doesn't matter whether we are going to use the change method or not. So that means this change method doesn't work. It's only affects the values inside. So let's take a look. Why? Here he says that for a parameters of a primitive type value, the actual value is passed, right? The actual value is passed. Suppose we are passing 5 here. And then the 5 is passed as to x. However, changing the value of a local parameter inside the method doesn't affect the value of the variable outside the method. Since it is inside the method, x is 10. It has been changed. However, once we get out of the change method and moving to the print here, it doesn't affect of the variable value. That means this x should be consistent with the first line x. However, for a parameter of an array type, the value of the parameter contains a reference to an array. That means contains the address, right? We have mentioned earlier in our lectures. This reference is passed to the method. Any changes to the array that occur inside the method will affect the original array. Will affect, remember. That means if we are passing array here, for example, we are passing array here, it will affect the original array that passed to the arguments. Let me see. Okay, there is an example here. For example, here, suppose x is 1. And we declare an array that is y. So that means currently I have an x that is 1, and I have an array y. I have 10 elements. Okay, we invoke m with arguments x and y. Okay, let's see. We go to this method. So x will pass to here, then pass to number, and y will goes to here. So number here is 1001. So that means x, since we pass the x to the number currently supposed to be 1, right? Here inside the method, number is supposed to be x, that is equal to 1. And however, here it updates a new value to the number. So the number is supposed to be 1001. However, we also pass the numbers there. That is y, 10 elements, right? And it set the number 0 as 55555. That means here it is 5555. Since we say that, let's go back to the first slide, the previous slides. Contain for a parameters of an array type, the value of the parameters contain a reference to an array. This reference is passed to the method. Any changes to the array that occur inside the method will affect the original array that passed the argument. So that means inside this void m method, we change the first element of the array numbers here, right? It will affect the original method that reference to the y. So here it will also will update to 5555. However, the 1 keeps the same. X is still equal to 1. And that is the difference between the pass by value and the pass by reference. And let's take a look over the call stack. In the call stack, we have activation record for the main method. Here is the x is equal to 1 is value. However, for the integer y, it's a reference because y, the variable name reference to an address that contains 10 elements there. This is a reference. And when we are invoking the m method xy, the value of x and the y's are passed to the number and the numbers. Here, 1 goes to the number. So in the m method, the number is assigned the value of 1. And for the numbers array, it gets the reference to the y. So the reference here is the same with the reference here. When we are talking about the array, so when we are creating the array, usually the reference, I mean the address, is always pointing to the heap. Currently, you may not know what is a heap, but in the future, if you are taking the computer architecture course, you will learn a lot of it. A heap is something actually grows to it is still something looks like a stack, but they are growing in a different direction. For a stack, usually it goes from this direction, from the top down. But for heap, it goes from bottom to top. But in our course, we will not get too much of it. What you have to know is that a reference always pointing to an address in the heap. And the arrays are stored in the heap. Here is an array of 10 int values. You can taking them as, okay, there is 10 elements. 1, 2, 3, 4, 5, 6, 10. 10 elements. Index from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And okay, once we have copy paste the values to the number and numbers here. And the Y contains the reference values to the array, and the numbers now contains the same reference to the same array. So let's go to next one. When we are invoking the method, the value of X and Y are passed to them. Here, the activation record A here, it refers to an array, right? A0 is 1, A1 is 2. However, okay, this is a swap. Okay, here is heap. It refers to here. And when we are calling the swap method, we are taking N1 and N2. So 1 and 2 will change their place. For example, here, for the first one, A0, 1 here will go to here, and A2 go to here. They are different, right? Because here we say activation record for the swap first two in array method. All right, it already said that it's a swap first two elements in the array. So once we have done with it, the first one and the second one, the position will be swapped. And the JVM stores the array in an area of memory called heap. We just talked about it, right? Which is used for dynamic memory allocation, where blocks of memories are allocated and freed in an arbitrary order. You don't know where you... Actually, heap is a pretty flexible memory space that the JVM will assign the starting point of the array and the end point of the array. You don't know where the place will be located. You don't know. Only the JVM know. That's why it's called a dynamic memory allocation. That means you can create it at any time you wish and any place it can be. Okay, let's get back to the passing arrays as arguments. The objective is that we are going to demonstrate differences of passing primitive data type variables and array variables. let's take a look over the examples extended from the previous slide here. Okay, we are invoke swap method. We are going to invoke such a method, N1 and N2. The primary type values in A0 and A1 are passed to the swap method. Okay, as we can see, it passed to the method. And the arrays are stored in a heap. Invoke swap first two in arrays. The reference values in A is passed to the swap first two method. That means here space required for the main method. We have a reference here. And also we have a reference here. Both of the, since they are the same reference because we are given this one to this one. So these two are pointing to the same array. That is pointing here. So that is the pass by reference, as you know. So as you can see, the reference, everything, for example, let's give it value OX2EEFFF. So here it is also OX2EEFFF. Everything, the reference is the same because it's pointing to an address. And that means here the starting point address is OX2EEFFF. That is passed by the reference. If we are passing by the values, we only pass the 2 to 2, 1 to 1, right? We don't pass the address. We only pass the value. That is the difference. Okay, and then let's take a look over returning array from the method. Here is we returning an array. Let's see, suppose here we are creating a new array named result. We only create it, but we don't initialize anything to it, right? We only declare it. It's a result. And here we have using a for loop that iterates from the same length as the result. For example, we already have a list here. Suppose it has 1, 2, 3, 4 something, right? And the list and the result are the same length, as we can see, same length. Here we are going to reverse the list. That means, okay, if we are starting from the 0 and ending at the result J point, suppose it is 0 and this is 9. We have 10 elements, okay? So here we say we give the last element of result by the value of the first element of list. That is, we given the first one value to here. And the second one here, 1, 2, 3, 4, right? That is the change the order of the list. And once we are completing with the result, here, suppose it is 9. We will return the result rather the list because we want to reverse the initial list. That's it. So since the result is a reference, it's supposed to be an address. For example, this address is OX444EF, right? And here this address is OX666CF. What we'll have to return the result here actually is pointing to this address. That is, return the OX666CF. and the whole 10 elements will be returned to the variables who called it. That is the list2. So list2 will take over the result and pointing to the array. Okay, let's trace the reverse method step by step. Here in the first line, we declare the result and create an array, right? As we can see. And the default value is 0, 0, 0. And inside the for loop, we have two elements, I and j. I point to the index 0 and j points to the index 5, which is the last element. And when I is less than 6, we will implement the code inside the for loop. Inside for loop, we assign the list 0 because currently I is equal to 0 and j is equal to 5. We assign the element in list 0, that is 1, to the result 5. That is the last element in the result. So the 1 goes here. And after that, I plus plus, j minus minus, that means I is shifting 1 position away from the original. That means here the I, initially I is here and then it moves here. And for j initially is here and then it now moves here. Now j is removed. And currently I is equal to 1 is also less than 6. So that means we'll have to implement the code in between. That is, we assign the list 1 to result 4. We move the 2 to the result 4. And after this, we conduct the same thing. I moves 1 position next, and the j moves 1 forward. And then we implement the code in the for loop. That is, assign the list I, which is the value 3, to the result j as 3. And after that, same thing for the cursor I and the cursor j. Okay, let's quickly go through this program. And once we reversed all the lists, and then we got a new array list named the result, right? And then we return this result to the list2. So list2 will have currently take over the result array. So here we say that a main method is just a regular method. You can call a regular method by passing actual parameters. Can you pass arguments to main? Of course, yes. For example, the main method in class B is invoked by a method in A as shown below. For example, let's see here. In the class A, we have a main method there, right? And thus we declare a string, the string array. That means it is an array and all its elements are the type string. The first element is New York. The second one is Boston. The third one is Atlanta, right? And then we call a method b.main, and we pass the strings here. Okay, let's see what is b.main string. In the main class in B, it says that for I is equal to 0, I smaller than arcs length. Okay, what is arcs? Here, the arcs referring to this arcs, right? So in this example, the length is 3. So arc 3 args.length is also equal to 3. And in this main method, the for loop will print out each element in the args. So the args is equal to the strings here. So that we pass all the strings. We pass the New York, Boston, Atlanta to the args. And the args will be printed out by the class B. So main method is just a regular method, and you can invoke it by another method. Let's see what is an array.toString list method. This method can be used to return a string representation for the list. That means you can reorganize it for the value, for the parameters you pass to it. This one. Let's take a look. Okay, we don't have an example for it. Let me check. Why we don't have examples for that? Let me get an example. Wait a moment. Okay, I have an example here. Let's see this example. Here we have a class named card, right? We have two attributes. One is the face, one is the suit. Okay, the face of card, you can say egg, deuce. And the suit of the card is hearts, diamonds. It's okay. And we have a constructor to initialize the card's face and suit. Here, we say that default of the face is card face. Default suit is the card suit, initialize the suit of card. And then we have a toString method. As we just mentioned, the toString method is a representation of a specific method that it returns something. Like, for example, it will return the face of suit. That means if we are calling the constructor by default, the face is the card face. It will return card face of suit, card suit to it. It's just to representing of something. Or you can also write like return its face plus of plus suit. That means it's kind of like formatting it. And we will discuss it in our lab because it's quite a little bit difficult to understand what is a toString method. But it's okay. Just at this moment, what you have to do is just have a notion of it. That's enough. And then we will get in touch with something related to the two-dimensional arrays. Because we only have 4 weeks, and we still have to take in our exams 3 with the finals. So we have to speed up our learning pace. Okay, here, let's see the motivation. We just previously introduced what is one-dimensional arrays, right? Like we have an array is something that's multiple dimension, a collection of elements, right? It is one-dimensional, and they are the same type. 1, 2, 3, 4, 5, and from the index 0, 0, 1, 2, 3, 4. This is the index. This is one-dimensional array. However, you can using two-dimensional arrays to represent a matrix or a table. A two-dimensional array. For example, this distance Oh, sorry, I'm muted. Sorry. I don't know why it automatically muted me. Okay, let's go continue. And okay, and we still need one outer curly brackets there. So that is the way how we can declare the two-dimensional arrays. Here. The outer curly brackets here and the nested curly brackets there. Okay, let's see the formally declare and creating the array. This is a template. Okay, data type. data type here and the name for the array. So after the data type is created, this is the declaration, and this is the first kind. This is declaration, this is the creation. However, we can also combining the declaration and the creation in one statement. So this is a second way. And this is the third way. It's quite similar with the one-dimensional array, right? In the one-dimensional array, we only have one of this. We only have one. But here we have two. We have two brackets there. And let's see how can we declaring variables of two-dimensional arrays and creating two-dimensional arrays. Okay, let's record. The first one is data type here, right? Data type with two. Here is the data type with two, right? It's also data type with two. But here is arrays variable name, matrix. It's corresponding to here. Everything almost looks similar as the one-dimensional array. And then we knew something. We're using the keyword new and the data type two-dimensional, right? And here is how can we assign value. If we don't do that, the default value 0 will be assigned to each element. What if we have three-dimensional? Okay, it's supposed to be the same way. We can use something like int 3. Okay, we say it's not a matrix, it's a cube. It's new int 10, 10, 10. It's pretty mechanism. And inside the for loop here is to assign the value. To each element. For int I is equal to 0, I is smaller than matrix dot length. The matrix dot length referring to the first dimension of the matrix, that is 10. Also, I would admit that they are the same, right? 10, 10. So here is the 10. And for the second line, the nested for loop, it's starting from j is equal to 0 to j smaller than the second dimension. That is also 10. However, the difference is first is referring to the matrix. However, inside nested, the second dimension is matrix I. Why we have it? For example, let's go back to this one. Here, 1, 2, 3, 4, 5, 6, 7. Okay, it's a 7. This one is 1, 2, 3, 4, 5, 6, 7. 7 multiplied by 7, right? This is two dimension. Because it has 7 rows and 7 columns. Usually the first dimension is referring to this one. This is the first dimension row. And here is the dimension column. This is the second one. We say it is okay, this is distance. Okay, actually, let me write it more clear. We're usually using I to indicate the row and J indicates the column. So that means here is the distance I, right? So we have distance I to the last line would be distance 6 because I is increasing from 0 to 6. So here is distance 0. And once we have got the row numbers, right, 0 to 6, so how can we get the dimension, the length for the column J? We say that we can use if we are using the first dimension, that is the distance 0. Okay, this is referring to the first line, first row of this matrix, right? Dot length, which referring to the first row size. But of course, you can also using the distance 6 dot length to referring to this row, the last row size. So let's go to here. That's why it has an I here, because the I is coming from here. It iterated the row from 0 to 10. And inside each row, it iterated from the column from 0 to 10 again. And here the matrix I, this one is referring to the row number. It's referring to the row size. The row size is the column size, right? However, if we are only using the matrix name, it will only giving you the row. And for the whole part, it's referring to the column. So I think next week we will have our lab, and in the lab we will do some experiments, so that will make you more clear how the two-ray and the one-ray dimensional indexing. Don't worry about that. We will practice in the class. So let's have a look over the illustration. Here we have a two-dimensional 5 multiplied by 5 keyboard here. It is the index 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 for the matrix new int. Here, the matrix length referring to the row that is going from here. And for the matrix 0, this referring to the row 1. That means it's referring to here. So if you are taking its length, right, you are taking this length. That is to be the 5. So that is the column. And let's take a look over the right-hand side. Let's see. Let me change the color. Here, we have the array that is the 4 multiplied by 3. Usually we go row first and then multiply by column. We have 4 rows and 3 columns, right? And the array length always referring to the row, number of rows. So that is 4. 1, 2, 3, 4, right? And for the array dot 0, here it referring to the first row, right? Row 1. It's referring to here. And we have only 3 elements there. So the length is 3. So that is the illustration of how the two-dimensional array organized in Java. I think it's pretty simple. And there are a lot of LeetCode problems related to the two-dimensional arrays. Usually they are medium difficulties. It's better for you to start earlier to practice them. So let's take a look over how can we declaring and creating initializing using shorthand notations. And here is the way we are declaring a 2D dimensional arrays for the matrix we just saw to present the distances between 7 different cities, right? Here we changed. Here is 4 by 3 matrix. And this is the shorthand notations to assign the value to it. Well, I should say this is a little bit complex because it's giving you the specific index, because here is 0, 1, 2, 0, 1, 2, 3, like 1, 0, 0, it is 1, so we assign 1 here, 2 here, right? We get the column plus by 1, column plus by 1, so it matches to the first line. It's a little bit, if we are assigning values in such a way, the things we have to type is a lot. But if we are declaring and initializing in the left-hand side way, it looks much, simpler and more natural. And let's record the length to calculate the 2D arrays. Actually, we say we have an X, right? The X is always, actually, for the 2D dimensionals, for the 3, 4, in the memory, they are not structured like the 3 rows. Actually, the 3 rows are concatenated together. For example, here is the first 3. After that is another 3. After that is another 3. After that is another 3. That means here points to here, here. Okay, I have only 4. Sorry, here. And this one goes directly here. So actually, in our memory, it's 1D, one-dimensional, but to make the code more natural and easy to read, we have to make them to looks like 2-dimensional. But however, you have to always remember that in the memory, they are 1-dimensional. And this is the matrix name, right? It's always pointing to the first element. Also here, it's point to here. The starting point here. And the X0 pointing to the first row of the element that is here. Actually, it is also pointing to the same way here. Okay, I think I should change the color. And for the X1, it's pointing to the second row's starting point. That is also pointing to the here. So in this case, you will know that in 2-dimensional arrays, for each row number, it refers to a specific location. For the columns, it owns. So that makes the way we are declaring the length for the matrix. Here for the X dot length, we are calculating the rows. For the X with an index, we are calculating the columns. Okay, let's see here. We say array length, right? Array length is referring to the rows. We have 1, 2, 3, 4, 4, right? The array with some index is referring to the column length. So that is 3. Here is 3, 3, 3. How about the array for length? Since we are zero base and we are only have 4, so the last index is array 3. If we are calling array 4.length, it will give you an error. That is the error index out of bound exception. And I think for today is enough because we have already covered 1D dimension and the 2D dimension. Maybe in the next week, we will go over the remaining of the 2D dimensions. But next week, we will doing our lab first. So if you have some questions, you can stay here. Otherwise, you can leave. For those who are not taking the exam 2, please do it quickly because if you are delaying too much, I will deduct you some more credits. If you submit earlier, you will get more. And if you have any questions regarding the exams, please let me know. Grades is just a small issue.